Welcome to section 4.3. We're doing right triangle trig. This is the algebra root 2 and geometry review section. I mean, this is back down to the special 45, 45, 90 triangles. I mean, we're going back to basics again. We are going to add in some questions where we're asking you to prove some identities, which really will tie us into chapter 5, but that's towards the end. So let's start by looking at the picture that's on page 301. Talks about this idea that if we have this right triangle, okay, we have an angle, and you can put your angle where you want. I'm going to put mine down in the bottom. My guess is you will have it there too. I can label the three sides of the triangle. The longest side is always the hypotenuse, so I'm going to label that first. Okay, so that's the hypotenuse. Then I label this side across from the angle, because across from the angle is the opposite. And then I always label the adjacent side last. That just seems to be habit. But then I know you're always guaranteed to get them right. Again, hypotenuse is the longest side, opposite is across from the angle, and adjacent is right next to it. And we're talking about the 6 trig values dealing with this triangle. Now, we talked about 3 of them yesterday. The sine of an angle, we said, was the opposite over the hypotenuse. I'm going to shorthand this a little bit. So the sine of the angle is opposite over hypotenuse. The cosine of the angle is the adjacent side over the hypotenuse. And the tangent of the angle is the opposite over the adjacent. And we said there was a phrase we learned in Algebra 2 called SOHCAHTOA. Now, there is a phrase that the 1012 building uses for SOHCAHTOA that maybe the freshman campus or other teachers haven't used. Not politically correct in any way, shape, or form, but let me tell you, it does click. So please do not get offended in any way. It's just a way to memorize this. So we say, some old hippie caught another hippie tripping on acid. Again, I'm going to say it completely not politically correct, but it works. Again, it's a way to remember these ratios as we go through. Some old hippie caught another hippie tripping on acid. Use it, don't use it. Maybe you already know SOHCAHTOA. It's completely up to you, but it is a helpful way to remember. What we're including this time is the reciprocal functions. And I'm going to shorthand them, but I'm going to say them in words as well. Cosecant is CSC of an angle. Cosecant is the reciprocal of the sine. Therefore, if I take the reciprocal of the two sides, it's the hypotenuse over the opposite. The reciprocal of a cosine is the secant of an angle. So the secant is the reciprocal of a cosine, which is then the hypotenuse over the adjacent. And the third one, cotangent, is the reciprocal of a tangent, which means it's the adjacent over the opposite. Now, I do not have a nice little phrase for that, because nothing seems to like 3 consonants in a row, and I'm having that problem in my life, right? Shapanic. So take a look. I don't know how you want to remember these. Here's the biggest thing, though, to keep in mind. If it was a sine, it goes to a cosecant. It starts with a C. If it started with a C for cosine, then it goes to an S for secant. The reciprocals never start with the same letter as their original functions, okay? Now, in geometry, we showed you special right triangles, and we had you memorize x square roots of 2, and x square roots of 3, or something like that. Truthfully, I don't remember them. So I'm just going to go back to this idea that if I make this a unit triangle, if it's a unit triangle, that means the hypotenuse is 1. And I'm looking at the fact that I have 45-degree angles. So this is an isosceles triangle. I'm going to go straight off the unit circle. If my radius is 1, or if my hypotenuse is 1, then I know my two sides for 45s are the square root of 2 over 2. Okay? And again, I don't remember these right triangles, even though I can label them. I go everything off the unit circle, so kind of keep that in mind. But take a look at this. What is the sine of 45? Well, if I look in terms of the right triangle, the sine of 45 is the opposite over hypotenuse. So the square root of 2 over 2 all divided by 1, which is the square root of 2 over 2. I'm going to kind of skip this thought and go to unit circle idea. What's the cosine of 45? Well, if I look at my unit circle, it's the x value. Therefore, it's the square root of 2 over 2. And the tangent of 45 is the sine divided by cosine. So I divide the square root of 2 over 2 by the square root of 2 over 2, and I get 1. The reciprocal functions are the harder. And I'm going to start with cotangent because that's the easiest. The cotangent of 45 is now cosine divided by sine. Maybe that's something you want written. Where do we want to put that? Let's go over here. The cotangent of an angle is the cosine of an angle divided by the sine of an angle. Keep that in mind. That's going to be handy for us later. But if I look at it, let me go back. Cotangent is the cosine, which is square root of 2 over 2, divided by the sine, which is the square root of 2 over 2. You get a value again of 1. In a 45, 45, 90 triangle, tangent and cotangent will be identical. Let's look at cosecant. Let me go back up to the cosecant of 45. I'm going to start with the original, and it's the reciprocal of this sign. So the reciprocal is 2 over the square root of 2. And we know mathematically we don't leave a square root in the denominator. So we're going to rationalize our denominator, get 2 square roots of 2 all over 2, which then gives us the square root of 2. Secant of 45, I do exactly the same thing. 2 divided by the square root of 2, and again, to save us a little time, it's the square root of 2 again. You will have to rationalize square roots, because again, all of this is no calculator. So kind of as you go through, keep that in mind. I'm going to do the 30, 60, 90 triangle as well, and then we'll look at some trig identities. The 30, 60, 90 triangle, I'm again going to relate to the unit circle. Here's my right triangle and my angle. I know then that the hypotenuse or the radius of my circle is 1. And you know what, I don't want theta. Let's make this the 60 degree. This is the 30 degree. What I know is that the opposite of 30, so opposite would be sine. The sine of 30 degrees is 1/2, and the sine of 60 degrees is the square root of 3 over 2. And I use my unit circle to figure that one out. But as I kind of look at this, let's go through. The sine of 30, and I'm not going to do the reciprocals on this one. I'm just going to do sine, cosine, and tangent. The sine of 30 is 1/2. We take this right off the unit circle. The cosine of 30 is the square root of 3 over 2. The tangent of 30 is where we got to do sine divided by cosine. 1/2 divided by the square root of 3 over 2 is 1/2 multiplied by the reciprocal of my denominator. 1 over the square root of 3 is not okay, so we rationalize our denominator, and you get the square root of 3 over 3. Now in Algebra 2, your teacher might have said to you, remember tangents of 30, 45, and 60, and I say no, use your math skills. Completely your choice in that, but again, it's worth it. You know, and instead of doing the 60 degrees, which you can take right off your unit circle, let's do the reciprocal functions for 30. Let's do the cosecant of 30, which is the reciprocal of a sine. So that's 2 over 1, which is just 2. The secant of 30 is the reciprocal, so 2 over the square root of 3. And when I rationalize, you get 2 square roots of 3 all over 3. And again, we expect rationalization is okay to do. The cotangent of 30 is the square root of 3 over 2 divided by 1/2, because I take these and flip them. In the long way, these end up canceling. You get the square root of 3, because the square root of 3 divided by 1 is just the square root of 3. So you can kind of see here what's going on. Again, tangent, cotangent, secants, I mean, all of these reciprocal functions, or where you're going to have to use division, we expect you can do it without a calculator and you know how to rationalize square roots. If you're not quite sure on that or you're not feeling comfortable, please come see me. Now I'm going to move this down so that I have all of the identities in one page. These identities, they say you take them from page 304. You know what? I'm going to walk through them because truthfully, these identities you have to know. Chapter 5, we expect that you know these from day 1 in chapter 5. We are going to give you 2 identities. And the only 2 identities we're going to give you are the last 2 Pythagorean identities. The rest of them you have to know. So let me kind of go through and give them to you because I'm going to show you why we're going to need them later. I'm going to start first. The sine of an angle is the same thing as the reciprocal of a cosecant. Let me go the other way. We're used to seeing the cosecant is the same thing as the reciprocal of a sine. These are just stating really the same type of thing, but again, the look is important that I show you this because we're going to prove some identities later. The cosine of an angle is 1 over the secant, or the reciprocal of a secant, and the secant of an angle is the reciprocal of a cosine. I'm pretty sure you can guess the last 2, but the tangent of an angle is 1 over the cotangent, and the cotangent of an angle is 1 over the tangent of an angle. These are called the reciprocal identities, and these you should know. My guess is you're used to these 3 the most, and the other ones really we're just kind of switching it up a bit. We've actually talked about the 2 quotient identities. The first one is that the tangent of an angle is the sine of an angle divided by the cosine of an angle. And we've used that basically the whole way through this lesson and last lesson. The one we introduced today was that the cotangent of an angle was its reciprocal, so cosine of an angle over sine of an angle. Those are important because, again, we're going to use those daily. The last 3 are called Pythagorean identities because they deal with the Pythagorean theorem. Okay? The first one we're going to use heavily. Sine squared of an angle plus cosine squared of an angle is 1. This one, you've got to know, or you're not going to survive this chapter. So if you're looking for ideas to memorize these or figure these out, I wholeheartedly suggest flashcards. 2 and 3 we're going to give you all the way through chapter 4, but at chapter 5, I don't give you any more. I expect you know. It's 1 plus the tangent squared of an angle equals the secant squared of an angle. And the third one, 1 plus cotangent squared of an angle is cosecant squared of an angle. So those 2 identities here, these are the only 2 that we will provide. The rest of them you need to know. Okay? And we're going to end up using these on the back side, so I wanted you guys to have these up front. Flashcards, memorize, whatever you need. This is definitely a must-have. So let's slide to the back. Let's start using these. As I look at question 1, they give you a triangle, and this is an Algebra 2 question. Okay? In Algebra 2, we'd give you this triangle, and we'd say, please write the 6 trig values. In this case, we're only going to ask you for the basic sine, cosine, tangent. In order to be able to do that, though, I have to know all 3 sides. And because this is a right triangle, in order to find this missing side, I'm going to use Pythagorean theorem. Call this x if you want, call it whatever you want, but I'm going to say x squared plus 3 squared equals 5 squared. And x squared plus 9 equals 25. So when I subtract 9, x squared is 16, and I square root. Now normally when you square root, you get positive or negative 4. But in this case, the negative isn't relevant because we're dealing with an actual triangle. So I don't need the negative. My side length is 4, but please keep in mind that when you square root, you do need 2 answers. Now that I have all 3 sides, I can actually start writing now my trig values. The sine of A is the opposite over the hypotenuse, so 3 over 5. The cosine, of A is the adjacent over hypotenuse, so 4 over 5. The tangent of angle A is the opposite over the adjacent, so 3/4. If we asked you then here for the reciprocal functions like cosecant of A, you would tell me 5/3. Secant of A is 5/4, and cotangent of A is 4/3. It wouldn't be too big of a deal. Please plan to know the other three and use the other three. You just will use them less than in here. Okay? So that's the basic. This is a basic Algebra 2 question. Number 2 is also an Algebra 2 question, and I'm going to show you 2 ways. The first thing they tell you is sine B is 0.8. 0.8 is a nice decimal. If you were to math fraction this decimal, you would find it's 4/5. The Algebra 2 way would be to draw a triangle and find 4/5 and go and exactly do what we did before to find B, or to find the other side and go from there. But this is the Algebra 2 way. Okay, I'm going to show you the pre-calc way. The pre-calc way says, let me use the identity sine squared, and I'll use B, plus cosine squared B equals 1. Okay, so I'm going to go through. Sine is 0.8, so I have 0.8 squared plus cosine squared should equal 1. 0.8 squared, well 8 squared is 64, so you get 0.64 plus cosine squared equals 1. And when I subtract 0.64, cosine squared is 0.36. Similar idea, if I square root both sides, the cosine of B, well the square root of 36 is 6, so 0.6. This is the pre-calc way. And I know there's decimals, guys, but we're giving you nice enough decimals that we feel like this is a no calculator question. Now, how do you find the tangent? I'm going to again take it the pre-calc way. The tangent of B is the sine of B over the cosine of B. So, sine is 0.8 divided by 0.6, which is really 8 over 6, because they're the same decimals if I multiply by 10. And 8 over 6 reduces to 4/3. And so this is the idea, again, this is what we want you to see. Now 4/3 you definitely could have found from this triangle because you would have said this is 3, so tangent is opposite over adjacent. I get that. We want you starting to think in the mindset of these identities and these so that you can get comfortable with them because we're going to use them all the time. Okay, so let me take you through another identity. I'm going to slide this down a minute. In number 3, if the tangent is 2, let's find the cotangent and the secant. All right, let's start with the easiest. Cotangent of Q is the reciprocal of the tangent, right? So therefore the cotangent would be 1/2. That's the easy one. Now secant. We want to know if there is a relationship between tangent and secant, and there is. The Pythagorean identity says 1 plus tangent squared equals secant squared. Okay, so we're going to use this idea. 1 plus the tangent is 2, so 2 squared will equal secant squared. Well, 4 plus 1 is 5, so 5 is secant squared. And when I square root, I want it left as an exact value of the square root of 5. Again, I don't need a negative because we're talking in relation about triangles, and the sides of a triangle will never be negative. If they ask you, though, to round to the nearest hundredth, it'd be 2.24. But again, I would love the exact value as opposed to the decimal. Okay? This identity, again, we give you. Oh my gosh, you're going to profit so much, though, if you know it, instead of having to rely on us. Number 4 is the most difficult, I think, in this section because we're really going to change your thought process, not from just sine, cosine, tangent basics to how everything interrelates. We're asking you to prove an identity. And if you notice, the left side of this identity looks worse than the right side. My goal then is to get this left side to look like the right side. Well, I'm trying to add two fractions. In order to have two fractions added together, I need a common denominator. So I'm going to multiply this first fraction by the sign, and I'm going to multiply the second fraction by the cosine, so that my denominator is sine times cosine on both sides. Okay, so let me go like this. Sine times sine is sine squared. And on the denominator, I have sine times cosine. Plus, cosine times cosine is cosine squared. And the denominator again is sine times cosine. Now, I can add these two fractions together now because the denominators are the same. And if you look, I'm going to add sine squared plus cosine squared. That's an identity you have to know. Sine squared plus cosine squared equals 1 over sine of an angle times cosine of an angle. Now take a look. 1 over sine is cosecant. 1 over cosine is secant. I have just proven that these identities are identical. And we want you to show that one side equals the original of the other side. Eventually we'll manipulate both sides, but as of right now, the ones we're going to give you are going to be easy enough that we only have to work with one side. Okay? Again, we will have more identities, and we're going to slowly bring those into this chapter, and then chapter 5 is all identities. We have one last example to do. This is an Algebra 2 example. Suppose Mr. Wilcox and his friend Rally Matt are trying to build a jump to test out a new rally car that they race. They need the jump, well, let's make our jump, shall we? We need our jump to be 10 feet tall with an angle of elevation. That means from the ground up, so we want that to be 21 degrees. Excuse me. How long will the actual jump be? The jump is this ramp. How long will this be? Okay, so Algebra 2, let's go back. What two sides do we have? We have the opposite and the hypotenuse that we're trying to find. Therefore, opposite and hypotenuse need sine. So we're going to say that the sine of 21 degrees equals 10 over x. Whatever you do, please make sure your calculator mode is in degree mode since we're working with degrees. And I'm going to multiply by x on both sides because I don't want x in a denominator. So I have x times the sine of 21 equals 10. And I'm going to divide by the sine of 21. Therefore, I stick this in my calculator, and x is approximately 27.9. It's a story problem, so don't forget a label. My ramp needs to be about 27.9 or 28 feet. I'm okay with rounding there. Okay? So that's section 4.3. This is really the Algebra 2 section. The only difference is this identity up top, and there will be some identities that we're asking you to look at today. My number one thing with identities is you attempt every identity. You're not going to get better unless you attempt them. So that's section 4.3. You will have a quiz 4.1 to 4.3 coming up. Again, part is calculator, part is no calculator. Please, please, please try everything you can without a calculator. And so far, the only one we've needed a calculator for is this last one.